Good morning to all. We know we have crossed a very difficult and tough situation during 2020. I hope now this year 2021 bring peace, prosperous and happy year for all. Let us march forward with new inspiration for our progress and prosperity. In my opinion, a sunset is not end of the day. Sunset is a process of beginning of new bright sunny day. Every black moon night followed by a full moon night. We should mentally prepared to welcome our bright future from this 2021. We lost many of our nearest and dearest one, and I pray God for the eternal peace of those departed souls. I pray God for well of everybody. Today, I want to discuss about approximate relationship between rock engineering properties in foundation analysis. Basically, for a rock in case of foundation engineering, we are generally trying to estimate the ECS value, the compressive strength, dry unit weight, that is dry density, water absorption, void index, specificity, spatial and stress-strain relationship. In many cases, we are not crossing the other parameters in case of foundation engineering. In case of using rock as a construction materials, we require some other parameters like impact value, crushing index, point load. There's a lot of other parameters are required. But in foundation engineering, whether it is shallow open foundation or deep well foundation or pile foundation or rock anchorage or rock bolting, rock socketing, we need UCS, that is Uniaxial compressive strength, and stress-strain relationship, stress-stress relationship required for estimation of anticipated settlement. In case of rock, settlement is not a major criteria because shear is the governing factor of rock mass. In rock bed, there are a lot of joints, fractures, slip, uneven surface. So there are chances of slip and shear along these joints or fractures. So settlement is not major criteria, although in IS code there is a permissible limit of 12 millimeter. No rock specimen could stand up to 12 millimeter. Before that, it will shear. During my last 52 years, I never measure and strain up to 12 millimeter. Not even 1 millimeter I have so far measured. However, the application of UCS is a major parameters in foundation engineering in rock bed. Our Indian Standard Codes or Indian Road Congress specification or Indian Railway Board technical specification, whatever may be, everywhere they are based on compressive strength, that is UCS value. UCS means earlier it is unconfined compressive strength, because there was no lateral support, it is unsupported laterally. But now it is called UCS, Uniaxial, since action, applied force and reaction at a base in same axis, in one axis, so it is UCS. Let us see how we are using this. Rule 6.2 of IS 12070, it is safe bearing capacity is UCS NJ. They donated QC and NJ. QC is UCS value and NJ is bearing capacity factor depending upon the spacing, distance of joints, thickness of joints, soil fill of joints, and it is partially derivative of RQD. Not exactly RQD. If there are joints are very frequent, NG shall be less. If there is no joints, there will be NB will be too high. In other equation, in pile load capacity, IS 2911 part 1 section 2, ultimate load is shear strength NC AP, that is in bearing. NC is a bearing capacity factor. Normally it is considered as 9, considering phi equal to 0, so it is NC is 5.14 circular base, so circular base is 1.3 and depth factor is 1.33. ultimately NC became 9. AP is tip area plus alpha means adhesive factor shear strength pi BL. B is diameter, L is length. So it is, this component is surface area and this is as shear strength. Alpha is, some says it is 0.5, some says it is 0.7, but it is soil concrete reaction coefficient. It is adhesive factor is nothing but a soil concrete reaction coefficient. For soil it is 0.5 and for rock it is 0.7. If it is steel it is 0.27, like that. You see, again see IRC 78 rule 9.1 KSP is a earth pressure coefficient, UCS DF AP. AP is point area, that is tip area or base area, plus surface area strength. So ultimately shear strength S or QC is directly UCS, and S and this S is derivative of UCS. Normally it is half of UCS value. It appears that UCS value is the most important parameter in foundation analysis in case of rock bed. However, we are not always getting appropriate rock core. Appropriate rock core means for UCS analysis, our test specimen required twice diameter. If diameter is say 50 mm, then our length should be 10 cm. So in some people, they prefer that the bigger size of core is much better, then it will be very easy to get good cores. But joints, nobody knows where is the joints, where is the cracks, where is the fractures. These are the cracks, these are the joints, these already lissing lines are there. These lissing lines are there. These are all joints and fractures. In this bore, you see, from here 0 to up to it is about 7-8 meter. We are not getting a good core. If we go for Archidio analysis, in case of this will be a good core for Archidio. It is more than 10 centimeter. Archidio reflect the minimum numbers of minimum core having a length of more than 10 centimeter. So in case of 100% Archidio also, for 90 centimeter dia, for PX dia more than 10 centimeter cores, maybe Archidio may be 100%, but for PX dia we require about 19 centimeter, about 19 to 20 centimeter. So 10 centimeter greater than 11 centimeter or 12 centimeter cores will be sufficient for our Archidio, which give us 100% Archidio value. It does not mean that there is no joints. Joints may be there, and our requirement is based on twice D. That to 3 pieces are required for conducting UCS test. So here it is, you see in this bore you see these joints. These are the joints. Here only this piece only. Here it is one piece. Here it is 1 piece. We are getting 3 pieces. A 20 meter deep hole. There are we are getting 3 pieces only. And up to 8 meter there is no piece at all for laboratory analysis, laboratory determination of compressive strength. Next, in this bore, you see, in this bore, this is also a 20 meter bore. Here 1 piece is there. Say we can go for 2 piece here, and 1 piece here. We are getting 3 piece only. That means in 20 meter bore we can go for UCS test, 1 set of UCS test. People always suggest is larger the core diameter, better for efficiency and purposeful results. but I do not agree with. Maximum hole size shall be, the only hole size shall be annexed so that we can be within the framework of RQD and our UCS criteria fulfillment. Because if it is 55 mm core, our length is required 11 mm, slightly more than the RQD requirement. So it is always better to go for annex core drilling for all practical purposes. You see, this annex size cores with sectioning of test specimen. Test specimen is L equal to 2D. The T is actually, it should be specimen, not speciment. It was wrongly typed. Length equal to twice diameter. So we have required to be section properly using diamond core cutter. And next step, we have to polish it for uniform level base. If it is ununiform, strength will be misleading, so it should be polished properly. And then after polish, we should measure the diameter, length and diameter, because our requirement is 2D. It is 12 mm. Now after polishing, it should be almost 11 mm. Little bit here and little bit here, it should be removed during polish, so it will be coming 11 cm. Next you see, it is 54.77. Instead of 54.77, we are considering it is as a 55. What happened? New bits, they give little less than 55 mm, and old bits, it gives little more than 55. The average is 55. It is annex size. So we are confirming the diameter is 55 mm and length is 11 mm. Next step of this test specimen should be soaked in water bath for 72 hours. There are two purposes. Number one, any dust or dirt inside the surface during drilling operation, the cutting spoils. Some amount of cutting spoils maybe remain inside some pores. To remove that, we have to soak underwater for 72 hours and later on we shall dry completely as far as possible to zero moisture content before analysis. You see, this is the UCS test. In this test, we are applying a load from the top and getting the reaction from the bottom. A equal to R, action equal to reaction. So we are getting force and this area, original area. It is not deformed area. It is original area. Deformed area we cannot consider. There are many reasons. Number one, at the failure point, dial gauges are not sufficient, they shall break down. When it fails, in case of soil, the failure slope will be gradual. In case of rock, failure is all of a sudden. There is no scope to measure the dial gauge. Though we are keeping literally, we are fixing dial gauges literally, but as soon as crack, it is not, all the dial gauges are damaged. So, and arithmetically, we cannot calculate the actual diameter. What shall be the failure diameter? Arithmetically, we cannot. Up to a very limited scope, say 0.1 millimeter or 0.01 millimeter, we can measure. After that, there is no scope at all. All of a sudden, cracks develop, and automatically we cannot measure the ultimate failure length, and so we cannot arithmetically calculate the failure area. So therefore, it is considered as load per original area. This is initial area. This is Uniaxial compressive strength. This is, you see, it is Brazilian method. It is tensile strength. Brazilian method, like concrete and steel, we can pull to measure the tensile strength, but in case of rock, we cannot pull. So Brazilian method, it is universally accepted by all. So in this method, there is no restriction of diameter and length. Any diameter, any length, we can use a test specimen. Here it is, we are using L equal to D. D is our 55 mm, L is 55 mm, and this 2P, P is pressure, applied pressure, divided by pi diameter L. So with this equation, we can calculate the tensile strength using Brazilian method. Now another easy and most conventional test is specific gravity. In this specific gravity, you cannot use big size of pores because the permeability of rock is so less, water cannot penetrate inside to ooze out the air from the voids. There are little amounts of void, there, but that voids cannot ooze out, say about 55 mm diameter course. It will be very difficult to drain out that amount of voids using water. So what general practice? To crush down the rock course to small pieces so that it can be saturated within a reasonable time. Normally 48 to 48 hours is sufficient. Some cases, more the hard rock, it will require little more time, but not more than 72 hours is required to drain out the pore water from the rock course. And from after that, the specific gravity is the ratio of weight of solid to the weight of equal volume of water. It is Archimedes' principle. We are determining the specific gravity from the equation. We have conducted a comparative study based on several thousand laboratory test results, UCS, tensile strength, density, water absorption, void ratio, etc. From earlier records also, we have calculated about thousands test results, and we conducted this study with Miss Pinky Gogoi and Nikat Begum, who were MTech students of Cotton University. They have conducted this study, and we successfully able to make conclusion of approximate equivalence and relationship between UCS and other test parameters. To this context, I am sincerely thankful to Miss Pinky and Miss Nikat for their dedicated services, which may be useful for our next generation. I say this is, you see, this is unconfined compression versus tensile strengths. USC, this is unconfined compressive strength versus tensile strength. This equation is tensile strength equal to 0.089 UCS minus 1.465. With this equation, we can, if we get tensile strength, we can calculate this accordingly. If we get compressive strength, we can calculate the tensile strength. This graph will be helpful for determining the engineering properties. When there are insufficient cores for UCS, small cores are available. From small cores, we can determine the tensile strength. And accordingly we can get unconfined compression also. From this equation also, with a rearrangement of equation, we can go for from tensile strength to go for UCS. See, this is specific gravity. Because for conducting specific gravity is very simple. This is the simplest test of rock mechanics. In rock engineering, only simplest test is density and specific gravity. So, with the help of specific gravity, we can also determine the unconfined compressive strength, that is UCS, Uniaxial compressive strength. I have some mistakes because actually I belong to long back. In our days, we are using foot inch. Now it is Newton millimeter. So the old terms still are in my lips and mouth. So uniaxial compressive strength versus specific gravity. From specific gravity also, I am not saying that it is 100% accurate. It is 34% accurate. You can say it is 35% accurate. But at least we can go for specific gravity, very simple method, and we can calculate the UCS with the specific gravity almost, more or less, almost purposefully. I am not saying that it is exactly, but purposefully. Even I want to add here, in same formation there are three pieces. We are required to conduct three tests of one set. In my whole career, I never get all three pieces give same results, with same effort, with same sincerity, with same precision, using same instrument. I am conducting several odd thousands of tests in rock samples, but yet never I get three samples give same value. There are some some amount of errors, whether it is human error or it is necessarily formation error. There may be many things which beyond our expectation and beyond our capabilities. So, using this specific gravity also, we can calculate the UCS values. Now you see void ratio. Normally void ratio of rock mass is void ratio. Hardly it is 0.01 to maximum 1% to maximum 3%. Normal range. Normal, which we call sound rock, it is 0.1% to 3% void charge, normal range. So from void ratio also, we can calculate the UCS values. If it is not for design purpose, but for checking purpose, it is purposeful. The equation is, relationship is 113 log exponent void ratio plus 1209. From this equation we can arrive approximate value of UCS. It is dry density is the simplest test. Like specific gravity is simplest test. Make a section, polish it, weigh it, calculate. There is absolutely nothing. Take a specimen, polish it, measure the length and diameter, and take the weight. This is. So from dry density also we can calculate the UCS. The equation is 13704 gamma is dry density, minus 35732, which is more than 50%, 51% correct, 51% correct. More the density, more the compressive strength. Less the density, less the compressive strength. So from this we can easily calculate the compressive strength from dry density also. Now the saturated density is from it is a simple arithmetical calculation between void ratio and dry density. Specific gravity, void ratio and dry density. This is simple arithmetical calculation. From saturated density also, saturated density is denoted as gamma S. It is denoted as gamma S, and UCS equal to 5381 gamma S minus 13640. It is almost 30% approximation. 30% accurate, it may be 50% approximation or like that. So from this also, all these are simple method I have explained so far. These are very simple method. With this simple method also, we can determine the UCS for our necessary purposes. Another, this is water absorption. Water absorption is arithmetic calculation. People say that millions and millions years this rock bed is under water, and what is this question of saturation? But this is the water absorption. Water absorption is its capacity. Up to a certain limit it will absorb water. Beyond that it will not absorb. Normally sound rock shall absorb maximum 1%, and soft rock it will slightly more. If it is more than 2%, the rock is soft or weathered rock. So from this water absorption also, the value of water absorption also, we can calculate UCS value, and this is the equation. UCS equal to 139.9 log exponent water absorption plus 807. From this also we can approximately estimate the UCS values. Now you see, it is, as I told, that it is very difficult to get proper core during drilling, especially in our neighboring country Bhutan, Nepal and India northeastern states. We are getting bedrock at a very shallow depth, and the top portion up to a reasonable depth, say 10, 12, 20 meter also, there are a lot of fractures, joints and soil fields are there. Since it is young Himalayan region, so under these conditions, to get perfect course 3-piece of requisite diameter, it is very difficult. So we have to bound to adopt simple alternatives to estimate the unconfined compressive strength from other test results. For this purpose, I have presented this simple approximation for all practical solution. And people normally say that there are some limits, and from n value also we can determine the SBC of rock. It is very interesting point. The n value mainly it covers the granular silty sandy soil only. Although we are having some approximation or empirical relationship of soil, clay soil or sandy soil like frictional angle and unconfined compressive strength, etc. But no way n value is related with rock engineering or rock mechanics. And n value 100 or 500 does not mean that rock is good or rock is bad. A small boulder may give you 500, even 1,000 numbers of blows. It does not mean that it is a hard rock of massive granite. It may not be. So I do not agree. In my opinion, unless and until you go for drill properly, you cannot say whether rock is sound or rock is poor. And RQD is a quality determination factor. Yes, I agree. But for laboratory testing, RQD has no relevant input in case of Uniaxial compressive strength, because 10 centimeter our smallest core is 55, so you require 11 centimeter. If we get 10 centimeter core, that means 1 centimeter we shall be input. Some derivative formulas are there. You have to use the derivative formula. Instead of going for derivative formula, why should we not directly calculate it from these other parameters we have already discussed here? I hope this discussion shall surely help you in estimation of required design parameters of rock mass for foundation analysis. In case of any clarification or any further information, I am always available at jcgogoi at gmail.com. I am saying again, jcgogoi at gmail.com. Wish you very, very prosperous New Year 2021. Goodbye 2020 forever. Please have a nice day.